गुड आफ्टरनून एवरीवन। स्टार्ट करते हैं। Design of the shaft. So simple design of the shaft we know. In strength of material we have learned lot of problems. Here in machine design we will see when shaft is mounted on the bearings and there is pulley, gears, many things are attached. So subjective lengthy problem we will solve. Okay. So write down here. First of all, shaft. Shaft. So what is shaft? It is a machine element. It is a machine element used to transmit the power and motion from to other, one rotating element to other, like gears, pulleys, flywheel. All these are mounted on the shaft. Yes or no? Hub, etc. Now there can be different type of loading on the shaft. There can be different type of loading on the shaft, as first axial loading. Axial loading. So when shaft will be under axial loading, simply its sigma t must be sigma t and sigma c must be less than equal to sigma yt or sigma yc respectively in case of ductile material, and sigma t and sigma c will be less than equal to sigma ut and uc in case of brittle material. Brittle material. ओके, सिंपल है. Here your sigma t and sigma c will be plus minus p by pi by 4 d square. So simple axial loading can be there. Then come to the bending. So in case of bending, here load is applied your p, plus minus p, and here bending moment will be applied. So when bending moment will be applied, sigma b will be equal to maximum plus minus m by z, and this will be plus minus 32 mb over pi d cube. Pi d cube. That's it. So this will be again your tensile or compressive. So it must be within limit like this, yield and ultimate strength, है ना. And in case of torsion, mt, there will be torsional shear strength. There will be torsional shear strength tau t applied, है ना. So there will be mt over zp. So value of this will be 16 mt over pi d cube. Okay. Here this torsional tau must be within limit, that is yield strength and shear. Yield strength and shear. So this will be the failure criteria. Now combined MT and MB and MT both are applied. In that case, we have studied this. In case of combined, the absolute tau max will be equal to 16 TE pi d cube, or you can write 16 by pi d cube under root MB square plus MT square. MB square plus MT square, like this. And here the sigma 1, when this you will check, so this will be equal to your 32 ME divided by pi d cube, and it will be equal to 16 over pi d cube into m plus m square plus t square. T square under root. So from here you will get the value of TE. It will become under root MB square MT square. And from here the value of equivalent moment you are getting 1 by 2 m plus m square plus t square. M square plus t square. Okay. M is actually MB. M is actually MB. So it will be MB. T is equal to MT. Notation समझ रहे होगे? We have already write down this in strength of material. So in this case, this must be within limit tau ys, and this must be within limit sigma ys, sigma yt or yc. Yes or no? So simple cases we know for the shaft, but in actual practice the shaft is subjected to multiple loads, and there are many things on the shaft like keyhole, stress concentration, dynamic loading. So strength of shaft will reduce due to all these factors. So for the design of shaft, ASME has given the standard codes. With the help of that ASME codes, we will design the shaft. Okay, so write down here. Write down here. When shaft is used, for power transmission, with the help of keys, couplings, etc., then due to presence of keyholes, or you can call it keyways. Stress concentration, fatigue loading, shock loading, shock or sudden, etc. The strength of shaft will decrease. The strength of shaft will decrease. So the design will be done as per ASME code. ASME codes. Okay. According to this, according to ASME codes, the shear strength or shear stress, maximum लिखो, maximum shear stress, the maximum shear stress produced in the material, produced in the shaft, must be limited to we will write down tau max must be less than equal to 0.3 times the sigma yt, or tau max must be less than 0.18 sigma ut, whichever is less, whichever is minimum लिख दो, whichever is minimum. Okay, so we will select the tau max like this, and also tau max must be less than 0.75 of tau maximum star when key holes are present. So if keyholes are present, then ASME code is saying maximum allowable shear stress is only 75% of the tau max star. Tau max star we know. Now to counter the effect, of reduced strength, new factors are also introduced. New factors are also introduced as one factor will be there Kb. It will be used with bending moment. Second factor will be Kt. This will be used for Mt. These are not previous Kb and Kt. Those were different. Okay. Those were different Kb, Kt in fatigue loading. These are different. And these Kb and Kt are more than equal to 1. These Kb and Kt are more than equal to 1. So as per the ASME codes, now the maximum shear strength by using these factors will be found like this. Kv factor with multiplied with the MB and KT factor will be multiplied with the MT. Okay. So this is the rule defined by the ASME. What is the full form of ASME? American Society for Mechanical Engineers और ऑल इंडिया सोसाइटी फॉर मैकेनिकल इंजीनियर, हाँ ऐसा ही कुछ है, कोई बात नहीं. नाउ केवी एंड केटी विल बी टेकन फ्रॉम द कोड्स. सो कोड्स आर गिवन लाइक दिस फॉर केवी एंड केटी. First will be for gradually applied load. Gradually applied load. Okay. So for gradually applied load, kV and kT will be given in the table. Second, sudden load when there is minor shock. And sudden load when there is major shock. Minor shock, major shock. So for this, kV value is 1.5 and this value is 1. This value is 1.5 to 2 and here 1 to 1.5. Here 2.0 to 3. Here 1.5 to 3.0. These are the values. These are the values. Okay. For kV and kT. For kV and kT. Like this. Okay. So kV and kT are the factors which must be used with bending moment and factor of twisting moment. So these we will check. Generally they give the value of kV and kT in the question. जैसे fatigue loading में they were used to give the value of Ka, Kb, Kc, Kd. In similar fashion they will give you the value of kV and kT. Okay.